So the first section of your test is just the common ideas. So I would like to know if you could figure out if these sequences are arithmetic, which means I add something every time, or geometric, where I multiply every time, or maybe it's not. Okay, so is there something that is the same thing going from here to here, here to here? Did you do something, either add or times, that's the same both times? Well, if I think about adding, that was 7, that was 7. So yeah, it's classified as an arithmetic then. Okay, I can kind of tell I'm not adding the same thing here because I went from a positive to a negative and I'm back to a positive, so I'm obviously not doing some kind of adding. So let's talk about timesing. If I went to that, I would have to times by -3. Does that also work? Again, if I times by -3, yep, it's consistent. So that one's classified as geometric. Okay, so if I test this one out with adding, I would have to add 2. From there to there, I'd have to add 7. So no, that's not arithmetic. What do you think about geometric? Would you times and times the same thing? No. So this is neither. It's nothing. Okay, do you see how I tried to trick you on that one? Because I did an add by 2 and a times by 2 to see if I could trick you, but you can't do that. Okay, do you do something the same? Are we adding 15, adding 15? No. Are you timesing the same? Times by 4. Oh yeah, that would work because I'd have to times by 4. So then it's geometric. Okay, so I can test out my adding strategy. So from 4 to -1, I would have to add a down 5. I'd go down 5. And from here to here, I would also go down 5. So that's an arithmetic. Okay, on F, if I'm testing adding, this would be up 4, and this would be up by 3. So I did not, it's not arithmetic. So I'm going to test geometric. What am I timesing by? Does anybody know what I'd have to times by to go there? What do you do if you don't see it? You take a term and divide. So this divided by this, does anybody know that in their head? Be a half, right? This divided by this, 4 divided by 8, negative, half. And then what would be that multiplier there? A quarter. So didn't pass any of the tests. Okay, I am going to give you a little bit of a hint here, actually. I found that sometimes writing these with the same bottom might help you see some stuff. So can we write these 3 fractions differently? What kind of bottom do you want to pick for them all that would work? I think 24 would be a good number. I can turn them all into 24 somehow, right? Okay, how do you want to change the first fraction into a 24? Times by what? 8, so 16. Turning the 6 into 24, I'm going to times by 4. And then that was just a 1. Can anybody see a pattern? If I just look at the tops really now. There was a 16 and then a 4 and then a 1. Is there something common with adding or timesing? Multiplying. So how do you go from a 16 to a 4 to a 4 and to a 1? You're timesing by a quarter. Okay, I'm going to do the same thing here. I'm going to put them all over the same bottom just to see if I can see a pattern. So I'm going to pick 6. 6, 6, 6. So then those are just 7 and 11. What is the first one? I'm going to times by a 3. So once you have them all as the same thing, would you see a pattern? 3 to a 7 to an 11. You're adding. You're going up by 4, 6, right? So arithmetic looks like I'm going up by 4 over 6. Okay, I'm going to do that again. What kind of bottom would you pick here? 18 would work. Okay, so times by 9, times by 3, times by 2. Okay, let's talk about, is it arithmetic? Yes or no? Let's rule this out. 9 to 3 is me going down 6, then I went down by 1. So, no. Geometric. Do I have the same timeser? So if you don't see it, we can do the process of divide by previous. Divide by previous. Term divided by previous term, term divided by previous term. Okay, dividing fractions, I'm going to flip multiply. So the 18s would cancel, so 2/3 is the timeser on that. Multiply, flip. Multiply, flip. The 18s would cancel, and this would be 3 over 9. So do they have the same multiplier? No. So that failed both of our tests. Okay, so that's on your test. Your part 1, when I'm going to say it's basics, I want to know, is it arithmetic, geometric, neither? And I'm going to say what is the R, what is the, what's the ratio, what's the pattern doing. Okay, do you have your formulas with you as well while we're going to do this next part? So you're going to get that on your test. You're going to get these. I will give them to you. How do I know if a formula is using arithmetic or geometric? Arithmetic has differences and geometric has ratios. Okay, that's how I know what's what. Okay, find the 8th term, and it doesn't even tell me if I'm arithmetic or geometric, so I have to figure out the pattern. so can you get me the pattern? It looks like I'm doing what? Arithmetic. I'm adding by fives. So the formula I'm going to pick is the arithmetic one, the term arithmetic. So term 8 equals term 1, so 7 plus n minus 1 times d. N is 8 because that's how many terms. N is the number of terms. Lots of this unit is just typing into your calculator properly. Make sure brackets are your friend. You can never have too many brackets. Okay, next one, I'm going to first figure out what's going on. So is it a common adder or a common multiplier? I can see that I'm multiplying by a -3. So I'm geometric. So I'm now going to use a formula over here with an R in it. So I'm going to use this one. Tn, the one with the R in it. So the 7th term equals okay, so there's my formula. R is the multiplier, -3. N is 7 because of the 7 terms. Okay, please don't ever type this into your calculator, 7 minus 1. You should just type in 6. Okay? So then you don't have to worry about another weird bracket. Make sure we're matching. Make sure you do that thing in your brain where you say, does my answer make sense? Okay, find the 6th term again, get the pattern. Figure this out. What's happening? Are you doing something common adding or common multiplying? So your answer should be that you're timesing by a half. Okay, so I'm going to use the same formula I just did here. Term 6 equals the first term. The ratio is a half. Again, I'm going to be putting a 5 as my exponent when I'm typing. And if you had a decimal answer or a fraction answer, there they both are. You can have one or the other. Doesn't matter to me. Does your answer make sense? Yeah, because look at me. I'm going, like I'm getting smaller. I'm getting smaller. I'm getting smaller, right? So by the time I'm 6th in the pattern, I should be smaller quite a bit. Okay, find the 10th term. So first of all, you decide if you're arithmetic or geo. So the pattern is doing what? Looks like we're heading down 8, down 8. So negative 8 is the adder. So which formula am I picking? The one that's arithmetic because it has a D in it. So term 10 equals the first term Okay, this is how I wrote it to you on my paper. This is somebody else's writing, and I'm going to deduct them a point. Can anybody tell me why I am deducting this person? They have a deduction.
They're subtracting 8 instead of multiplying.
Yeah. The way they wrote it, it looks like they're subtracting 8 instead of multiplying by the negative 8, okay? So that, I'm sure that they typed it in and wrote, they got the right answer, but just the way they wrote it to me on the paper was a communication error. Okay, so just be careful of that one. I get that one quite a bit. Okay, you know what we did? We already did this above. Do you see this one above? We already did the work for it. We did it on G. So we determined it was geometric, and we said that we're timesing by a quarter. Okay, so we did this work above. That's that same one. Okay, so find the fifth term. So I'm going to pick the geometric formula for terms. Okay, brackets again are your friend. Where your decimal is, you could move it 3 decimals to the left.
Oh, okay.
That's what yours did. You know what I mean? Because yours has the decimal here, and then it says to the negative 3. So 1, 2, 3. So yours is right, but it's doing scientific notation. So why? Recognize? I gotta move this. Do you have the same one? Okay, this question was above as well. We did it up here. So this one, we just said it was A, and that we're doing by a 4/6. Or 2/3, I don't know, whatever you want to use. Okay, so here we go. Term 5 equals arithmetic. So which one are you going to pick? This one with the D in it. So 1/2 plus 5 minus 1 times 2/3. Okay, I'm going to challenge you to do it on paper, not touching your calculator. Ready? Okay, good practice for grade 12 with your provincial. Okay, so this is a 4. 4 times 2 makes 8/3. Because 5 minus 1 was 4. 4 times the 2. Okay, so that was that. Now, can you give me the same bottom to add them together? There's a 2 here, a 3 here, so I'm going to pick a 6. There we go. Okay, figuring out the sums is the next part. Okay, you need to decide what's going on. Is there a pattern, and what kind of pattern is it? Add 3. Yep. So it's arithmetic. So do you know which formula that you would use? So you're going to use this one. This is the hardest formula to use. Why? Do you remember? Because often I don't give you that or that. One or the other. And you have to figure them out and then go. So we'll start here. We're going to figure out the sum of these 10 terms. So the formula says the first term plus the last term. So the first term is 6 plus the last term. I don't know the last term, as in the 10th term. We don't know the last term if we kept going. Times n, which is the number of terms. Well, I know that I'm going to do 10 terms. Okay, so now I'm going to figure this out separately. So I have another formula, so term 10. This is the formula. So term 10 equals term 1 So if you kept going in this sequence, the 10th position would be a 33. Does that make sense? Okay, now you got to run this formula through, so please type this in properly. You would have to do 6 plus 33 brackets, divide by 2. And see if we can match 195 on that one. So if I was to tell you kind of some of the harder parts of the test, I don't know why that one seems to be the harder one, because people get tricked with these unknowns and you got to figure them out first. That's all. That's good? Matching? Okay, so in B, get me a pattern. Get me a pattern there. Adding, timesing. So my timeser is 1/3. So I knew it was a fraction because I was getting smaller. Okay, so then I'm doing a sum. Okay, there's two formulas that have S in them. Which one do I use? SN, because I'm doing a sum of something specific. So I'm doing the sum of just 7. Okay, now I would say that this formula, it's not hard to use, but it's hard to type. So make sure you practice the typing on this one, because there's a lot of steps to this one. You're going to yell at me if we're not matching somebody? Think about what you're doing. You're adding 81 plus 27 plus 9 plus 3 plus 1. Da, da, da. So does my answer make sense? Okay, that was good. I can go to the next. Okay, so on C, I need you to figure out what's happening as a pattern. Is it arithmetic, geo? What's the pattern? Looks like I would be moving down 8, right? Down 8, down 8, arithmetic. So here's my formula that I'm working with, and this is the tricky formula. This is the one that sometimes I'm missing something. So the sum equals the first term plus the last term over 2 times the number of terms. So this time I don't know how many terms there are. This is the last term, but what position is it in? That's what you're going to figure out. Okay, I want to know what position that is in. How many did I go up to? So here we go. Formula for that, n. N equals the last term minus the first term last term minus first term over the difference. So I'm following the formula, plus 1. So n equals 6. On the test, I always get this. Somebody might answer me weird things like there are 2.7 terms. Does that make sense? No. there are negative 4 terms. Does that make sense? No. You can't have negative terms. You can't have a decimal amount of terms. This has to be a nice whole number. Okay, so figure this out again. Keep using brackets. Okay, good. Negative 60. Question D. Figure out the pattern. I'm timesing by negative 2. So I'm doing this formula, the sum with the r's in it, not sum infinite. I'm doing the sum of 9 terms. So again, this is the tricky type. So go slow and steady. Make sure you're doing brackets where you need to do brackets. Okay, 1197. Again, if I had somebody who wrote it like this, I'm going to give them a deduction point. They might still get this answer. Okay, but why do they not get full points?
No bracket around the
Bracket around the negative 2. Okay, negative 2 to the 9th versus negative 2 to the 9th. Okay, those mean different things in math. This one is lucky that it would come out the same number, but it's not that you're doing it right. 2 wrongs are making the right sometimes. Okay, this one, find the sum of the entire series or sequence. What does that mean? The infinite formula, and you can only do it with geometric, and you can only do it when your geometric is getting smaller, 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 which means your r is going to have to be a fraction, right, or a decimal. So on the first one, it looks like we're timesing by a half, right? So I'm going to go term 1, 8 over 1 minus a half. That's the formula. This one is a nice formula. Just make sure you put brackets on the bottom stuff. Okay, and the second one there is the same idea. Just tell me what the r is going to be on that. And it's again, it's going to be a fraction because you're getting smaller, 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 smaller. So it looks like I'm doing a quarter on that one. Okay, I have something to tell you on your test. I don't want you using I don't want you using this because it's going to throw off your answer. Does anybody know what I could change this into if I'm seeing this on my calculator?
1/3.
With a bunch of threes, it's really 1/3. I don't want you using 0.33 because it'll change your answer because you're rounding. What if somebody sees this and then they're using these decimals? Well, this one would be wrong. This would be at least better rounding. But I don't want you to use that. 2/3. Okay? So you probably see quite a bit of, when you see the thirds, make sure you recognize those decimals. Don't use the decimals, use the fractions. Okay. And then I would say this is one of the trickier questions. Term 5 is 15. So here's what I know. I know the 5th term is 15, the 9th term is -13, and it told me in the question that it's arithmetic. Okay, so here's what I know. If it's arithmetic, I'm going to add something, add something, add something, add something. Right? I'm adding something, adding something, adding something. I can already tell you I'm adding a negative number, right? Because I am down, I'm lower. Okay, so here's what we can figure out. How much did you change from 15 to -13? What's that whole span going to be? You went down 28. So what would you have done on each little jump? You jumped 4 jumps. So each jump is going to be -7. Okay, so that's called the difference. You're going to go down 7, down 7, down 7. Okay, now I need to figure out the first term. So I would technically have to go up 7, up 7, up 7, up 7. 1, 2, 3, 4 maneuvers. So 15 plus 28, 43. That's the first term. Okay, so this one, this is a geometric. Question B is geometric. 1, 2, 3, 4th term. Okay, so here's what I know. The 4th term is that, the 7th term is that, and we're trying to, again, figure out what's the first term. Okay, so what am I doing here? I'm going to times by something, times by something, times by something. Can you get me the whole distance? What's the timesor of the whole distance? So 8,019 divided by, so I times by 27. What kind of math is it going to be when I times by something, times by something, times by something? Does anybody know what's the same as doing that? Cubing. I times by something, times by something, times by something.
We have to do the.
Yeah. You can't do a divide by 3 if that's what you're thinking. That's something different. So, do you remember your button for that? We talked about the button on your calculator that does that. Some people have that special button.
How do you, where's that button?
So for me, I just go 3 first. And then I have this button right here called the X root of something. So then I have to push second that button. The X root of. Do you have a button that looks like that? So this means you can do any exponent. Shift that means you can do any root. Oh, because exponents and roots are the opposite of each other, right? Okay, get me to the first term now. So if I'm timesing, I would have to backtrack. How do I backtrack? Divide, divide, divide. Divide by 3, divide by 3, divide by 3, or divide by 3 cubed, because you repeated it 3 times. Did you get to 11? Okay, I'm going to give you 2 questions to do on your own that are this. Okay, so here's a question. You have to get me the first term.
Those are not fractions, right?
Okay, so this one would have been that you went up 24. So if I do that with 3 jumps, it means the common adder was 8. So then to go backtracking, I would have to go down 8, down 8, down 8, down 8. So I could go 21, subtract 8 times 4 maneuvers, getting me to a term 1 of negative 11. And the geometric, so all the way from there, if you do the divide, you should get 343. And then I timesed. So I did something repeated 3 times. So then I cube root it to get a timeser of 7. So I times by 7, times by 7, times by 7. So then to backtrack, I would have to divide by 7, divide by 7, divide by 7, divide by 7, or you could divide by 7 repeated 4 times. So then I got 3.